Hello everyone, my name is Kitana. I'm from Supermicro's Technology Enablement team. Today we'll be taking you inside the Supermicro HGX B200 family series. In the first segment, we'll explore the broad capabilities and innovations of the NVIDIA B200, focusing on what sets these systems apart in the market. We'll be introducing both the air-cooled and liquid-cooled version. Joining me today will be our marketing expert, Phil, who will share insights on unique features in these servers. All right, well, welcome in. Hi, my name's Kitana. How are you doing, Phil?
I'm doing quite well. How are you?
I'm stoked. I'm really excited that we're going to be talking about the B200, and I'm thrilled that I get to have a little bit of an insight. Can you tell me a little bit about it? What product offerings do we have?
So we have a variety of systems for the NVIDIA HGX B200, and that's with 8 interconnected GPUs.
Okay.
It's the industry standard system architecture for large-scale AI training and also AI inference. It's designed to scale to clusters. We have a liquid-cooled version in 4 rack units. We also have a 10U air-cooled version. So we have a variety of options depending on the thermal solution that your data center supports.
Okay, wonderful. And I think we might have one actually here.
Yeah, so we do have a 10U system. I see it right there in that rack. So that's going to be the SYS A22GA NBRT, or the AMD version is the A126GS NBR. And you can see there that it has a 6U GPU tray, so increase of 2 rack units for some expanded thermal headroom compared to the previous generation.
Cool. Can you tell me a little bit about the previous generations of before the B200? We're looking at systems such as H100 and H200, right?
Yeah, I see one over there.
Okay.
So that one, the previous generation was built around the 4th and 5th generation Intel Xeon processors. And there's also the AMD variant as well. It shares a lot of the same DNA, but it's designed to support specifically NVIDIA Hopper generation. So the NVIDIA HGX H100 and H200 8 GPU baseboard modules. Previous version also had 8 NICs, so that's 1 networking adapter for every single GPU. But there's some thermal optimizations that we did, spacing out the NIC adapters, some improvements in terms of the liquid cooling. The previous generation used these horizontal cooling distribution manifolds that do occupy 1 rack unit of space, whereas the next generation, or the current generation rather, the B200 generation, utilizes vertically mounted cooling distribution manifolds that are concealed inside the rack. Beyond that, there's the CPU, Intel Xeon 6, AMD EPYC 9005 series. Without going into all the minute details, the main thing is that those are up to 500 watt TDP dual socket CPUs.
Okay, so for the B200s, we have a choice of the Intel or AMDs, and that's in both the liquid cooling and air cooling. So you could choose either option that you want for cooling, also any option for the CPU.
Yeah, especially compared to some of our competitors. You can get as granular as the specific brand of the DIMMs that you want in there.
Okay.
If you have strong preferences of a particular vendor, Supermicro offers pretty much unmatched, unrivaled customization.
Love that, the building block solution that we're aiming for.
Yes, it's customizable at the system level, rack level, and data center level.
Could you provide me a high level of an overview of the system's architecture, the main components in there?
Okay, as I was mentioning, it is designed for large-scale AI training and also AI inference. So compared to, say, a traditional rack-mounted data center server, these GPU-optimized servers, first thing to note is that they're going to have a much higher GPU to CPU ratio.
Yes.
In the case of the HGX systems, it's going to be 8 GPUs for every 2 CPUs. Those 8 GPUs are interconnected in a local group on the baseboard with NVLink at 1.8 terabytes per second. So it creates this nice pool of high bandwidth memory, HBM3E. So that's in terms of the NVLink domain. There's also the in-memory domain.
Yeah, tell me a bit about that.
Well, in terms of Blackwell GPUs compared to Hopper, the big difference is that Blackwell uses dual GPU dies on a single die package, essentially doubling just the amount of GPU compute available.
The dual die.
Yes, so it's co-packaged.
So the Blackwell was the first that came out with that, right?
Yeah, Hopper was a single die and single package. Basically, Blackwell combines 2 GPUs in one, but even more than that. Not only does it do that, it also provides access for each of the GPU dies to a shared pool of HBM3E memory because of the advanced co-packaging that they use, which is called chip-on-wafer on substrate with local silicon interconnect. So in terms of the memory bandwidth, you're looking at double the memory bandwidth. That's what was mainly constraining GPU performance.
We definitely need that for all these giant models that are coming out.
Yeah, so it does provide a performance benefit for sure. Then beyond the in-memory domain, as I mentioned before, there's the NVLink domain. Essentially, it takes that and scales it up times 8. You have really large, I think it's 1.5 terabytes of HBM3E. So that's enough even within just only the 8 GPUs. Let's say you have a trained AI model and you want to deploy a production AI inference, then you're going to have a really, really fast access to high bandwidth memory, and you could fit multiple AI models and do real-time AI inference on a single HGX system.
I see. Okay, so instead of having to necessarily have racks and racks of H100s or H200s, you could do more with less.
You could, but I think that the primary use case is going to be these large clusters. I think that the ambitions of AI nowadays to create the latest foundation model is just so immense that Supermicro's customers are building out very, very large scale training clusters with up to 100,000 GPUs. That's kind of the next level of the computing domain in terms of the network domain, because the AI training applications require memory capacity far beyond that 1.5 terabytes of HBM3E that's provided by the 8 GPU NVLink domain. The traffic is going to be prioritized in the faster speed domain. Most of the calculations are going to be prioritized with the in-memory domain or the NVLink domain. But it's very important in the cluster for each GPU to be able to communicate very efficiently with each other GPU, even if they're in another system node over the network. So that's the purpose of having one networking adapter for every GPU.
I see. Scaling for this family is going to be very important, understanding the network and scale out.
Exactly, because these systems are designed from the ground up with scalability in mind. That's why you have these PCIe by 16 slots, like 8 of them that are intended for NVIDIA ConnectX 7 adapters or BlueField 3 SuperNICs.
If we wanted to go into the difference between the air-cooled and the liquid-cooled, for the liquid-cooled, do we have in-rack or in-row CDU?
Yes.
Do we have both options?
Yeah, for the liquid-cooled version, we offer both in-rack and in-row CDU options.
Okay, can you explain a little bit about them so that we can learn together?
Yeah, certainly. So really depends on your data center layout and also your rack layout. We lean towards doing in-rack CDUs.
Okay, why is that?
We do have a very robust in-rack CDU option that provides 250 kilowatts of cooling capacity. It's a far more headroom than is required by a standard rack elevation layout. There's also advantages of being able to validate and pre-configure the solution in the factory. It streamlines deployment. And having every rack having a dedicated pump with intelligent monitoring and control definitely provides some benefit. But if you want to have a powerful in-row CDU that's servicing multiple racks, then we also have that option available.
How does the NV switch enhance GPU to GPU communication within the B200 system?
Yeah, so the NV switch is really critical for achieving that 1.8 terabytes per second NVLink bandwidth. The previous generation of NVLink provided up to 900 gigabytes per second of bandwidth, whereas 5th generation NVLink switch provides up to 1.8 terabytes per second of bandwidth. So there are multiple NVLink switches that are on the baseboard itself. Basically, they're interconnected in such a way that local group of 8 can very quickly communicate with the GPUs within the baseboard.
So high throughput?
Yes, very high throughput and ability to communicate to any other GPU in the local group with basically the highest possible memory bandwidth, except for, compared to in-memory computing.
Understood. Okay, thank you for that. Diving a little bit deeper into the system, can you tell me a bit about the storage options that we have available and how do they support the high performance AI workloads?
Okay, on the system itself, it does support a variety of NVMe PCIe storage drives. So you have the two M.2 NVMe boot drives.
And those are all in the front, right?
Those are on the board.
Okay, gotcha.
On the front, you do have storage options. So you have up to 10 2.5-inch U.2 PCIe drives. So if you want to do like a converged compute and storage architecture, you could take that approach. Now, they're not like necessarily storage systems. So what we see most of our customers do is they'll have the AI compute fabric and then they'll have the AI storage fabric.
Oh, okay.
Yeah, so a separate network.
Understood.
But it's interconnected with the compute cluster. So you could have a kind of a, say, almost like a single file system that the AI application can readily access via the in-band management network facilitated by NVIDIA BlueField 3 DPUs.
That can be programmable?
Yeah.
Okay.
Programmable, yes. And also with the ability to load data directly from the storage fabric into GPU memory and bypass PCIe 5.0 limitations.
Wonderful.
That is the preferred approach for AI storage.
How does the one-on-one GPU to NIC ratio benefit these large-scale AI deployments?
So basically, the ambitions of these AI developers are just so great that having single systems is really not too helpful for them because they're not going to be able to develop anything that's novel. They're only going to be able to do AI inference of pre-trained AI models with a single system. So you need to scale outside of that. So 400G is like 400 gigabits per second. It's 1% of, I think it's like 1% of the memory bandwidth or 1% of NVLink speed. It's like a fraction of it, which sounds low, but it's like still, it's actually, it doesn't present nearly as much of a bottleneck as you would think. Because again, the data communication is going to be prioritized in the in-memory computing domain and the NVLink domain. But it's still really important that you have a full coherent network fabric because if you're doing AI training, if system nodes don't know what the other system nodes are doing, then the application is not going to work. So it has to be coherent across the entire cluster. It has to be cohesive, and the work that's been done on one node has to be known on another node to come together as like a final product.
Okay. We're going to be talking about some development and management. So what are the recommended rack configuration density options for deploying the B200 systems at scale for air and liquid cooling?
For liquid cooling, typically we do 48U rack enclosures. For whatever reason, 48U's standard for AI compute clusters. It's typically 8 system nodes per rack with one 4U in-rack CDU.
Okay.
Optionally, a rack-mounted leaf switches or out-of-band management switches. But those switches can also go in a separate switching rack. The main thing is those 8 system nodes in a rack. And the reason why 8 is used is because it's a nice number in terms of network topology. Like it is nice multiples of 8. Because you have network switches that offer 32 ports or 64 ports. It's also good for thermals. You're not like overstuffing the racks. The air-cooled version, on the other hand, is not going to be as dense because you have that 10U form factor. So we'll put 4 of those in a rack typically.
Understood.
In terms of software, you could pretty much use whatever software stack you want. We don't dictate like you have to use a specific type of software, whether we're talking about infrastructure management, software-defined storage, or enterprise AI software. Our solutions are validated with NVIDIA AI Enterprise if you want to easily deploy production-grade AI models and NVIDIA inference microservices. But you can certainly deploy any type of AI applications that you want.
I see. Okay. If I wanted to play around on this system, does Supermicro offer any of these online?
Yes. So Supermicro offers a program called JumpStart.
Okay.
That lets you remote into a server node. It's a great way to be able to test out your application and make sure that it works. Also, if you're working on a project with Supermicro, we also offer proof of concept service where you can even test your application on a multi-node cluster.
That's going to be exciting for those out there. What are the main reasons customers are choosing the B200 systems and this AI infrastructure? And do you have any success stories you could mention?
The main reason that people are choosing B200, same reason why people were gravitating towards the HGX H100 and H200. It really is like a streamlined solution for AI training, but also inference. And we've noticed that customers really like the capability to do both. So they're going to go for solutions that have large interconnected pools of very fast memory, GPU memory specifically. Customers right now are mainly comparing NVIDIA B200 with NVIDIA GB200 or GB300 NVL72.
Okay.
Also a solution that is streamlined for AI training and AI inference at scale. It comes down to whether you really need a 72 GPU NVLink domain versus an 8 GPU NVLink domain. It's not going to give you as big of a performance increase as you may expect, but it really depends on the application because, again, different applications are going to prioritize communication differently. So some are going to benefit more than others with a higher NVLink domain count.
Yeah, so there'll be some trade-offs. Is there any large developments that are potentially upcoming?
Yeah, I think so. I think right now to address the main bottlenecks. I think the transition to 800G network compute fabric is going to be significant, and that's basically happening now. Moving forward, looking towards B200 to B300, I think it's also going to be a significant improvement where per GPU you're going up from 192 gigabytes of HBM3E to 288 gigabytes of HBM3E. We've seen with H100 to H200, even just increasing the HBM3E capacity can double performance depending on the application and where you're bottlenecked. So we can expect to see those sort of gains this time around as well.
I really appreciate your time. Thank you so much, Phil.
Thank you.
And we'll be joining you again soon.
Thank you, Kitana. It was really nice to talk to you.
Thank you.
Okay. Here's our Supermicro NVIDIA HGX B200 GPU liquid-cooled server. So I'm going to show you guys the GPU tray. We have our Supermicro direct-to-chip cold plates that are attached to it, and that's going to draw out a lot of the heat, pretty much all the heat directly. And we have 8 GPUs and an 8 GPU NVLink domain at 1.8 terabytes per second interconnected. So now I'm going to show you the CPU tray. So let's slide it out. So you can see inside here, you do have some cooling fans to cool the components that are not liquid cooled. And then inside, you're going to have the CPU with that direct-to-chip copper cold plates drawing the heat away, in place of the AMD EPYC CPU or Intel Xeon 6. And over here, you can see there's a dedicated slot for the NVIDIA Bluefield 3 GPU for connecting to an in-band management network, so for like a attached storage fabric. One other thing that I want to show you is the module for the networking adapters, so the NICs. And this system supports 8 NVIDIA ConnectX 7 400G adapters. So if you use something like a Bluefield 3 Super NIC, you can also use it with NVIDIA Spectrum X Ethernet. This one is set up with ConnectX 7 for use with an InfiniBand network. And you can see here that there are the single slot PCIe 5.0 cards that have a nice spacing between them to give them more thermal headroom so they can avoid overheating. And the great thing about this is that you can unscrew and just slide out the NIC module, the entire NIC module, so it makes it really easy for servicing without having to take out everything. Lastly, you got your 4 redundant power supplies. That's going to give you plenty of power capacity with headroom to spare, as well as that redundancy to reduce failure.
Thank you so much for joining us today on the deep dive for Supermicro's HGX B200 series. Note that this is part 1, we have a part 2, so be sure to follow up in our next video, where we'll have a more technical discussion with Patrick Fallon, Technology Enablement Engineer. Whether you're interested in AI, high-performance computing, or the latest in server technology, we hope you found this overview and technical discussion valuable. For those interested in testing out a system, please reach out to a member of our team. If you have any questions or want to learn more, please leave a comment below or reach out to a member of our team. Don't forget to like and subscribe